One of the major threats to transformers is the wetness of their windings. This may happen due to weather effects, during repairs, or given a number of other factors. Getting into the transformer and exceeding the allowable content, moisture can entail a number of negative consequences, including the deteriorated dielectric strength and dielectric properties of the insulation, as well as the limited maximum load of the transformer. The deterioration of dielectric characteristics leads to an increase in losses with higher than normal release of heat and, accordingly, to thermal breakdown and localized overheating of the insulation. Furthermore, moisture speeds up the processes of oxidation of transformer oil, thermal aging and degradation of cellulose, which leads to a decrease in the mechanical strength of paper insulation. Failure to maintain the moisture content within specified limits may result in transformer failure, power outages for consumers, and considerable financial losses for power distribution companies. In order to prevent the listed consequences, it is necessary to dry the transformer insulation on a periodic basis. Among the most common drying methods, we can distinguish drying with hot air, drying in a vacuum chamber, drying in the vapor phase, circulation of hot dehydrated oil with oil spraying and vacuuming. However, these methods have disadvantages that disallow the drying process to be as efficient as possible. The disadvantage of drying with hot air is the non-uniform warm-up of the insulation. The efficiency of vacuum ovens significantly depends on the method of heating the windings insulation. The method of drying in the vapor phase requires expensive equipment of special design, since a solvent is an explosive substance. And the circulation of hot dehydrated oil with spraying and vacuuming is characterized by a long oil heating process, a high energy consumption, and the need to install spraying nozzles inside the winding of each transformer. In order to optimize the drying process, GlobeCore has developed a technology based on the integrated use of the low-frequency heating method in a vacuum oven. The low-frequency heating device drives a low-frequency current through the transformer windings. The windings are heated from the inside, a stable temperature is maintained and the heat is uniformly distributed. As a result, moisture effectively evaporates even from the deepest layers of the insulation. While the vacuum oven ensures faster and easier evaporation of this moisture. Let's consider in greater detail how the drying process works. At the preparation stage, the transformer windings are placed in the vacuum oven, which means a controlled medium where the pressure and the drying temperature can be regulated. Next, the windings are connected to the low-frequency heating device that warms them up deeply and uniformly. Along with heating, a vacuum is created in the oven. The vacuum decreases the boiling point of water, which allows the water steam to evaporate at lower temperatures, ensuring the fast and efficient moisture removal. Special vacuum chambers are being developed by GlobeCore in order to implement this method. The design of these chambers differs from that of conventional ones by the presence of connectors which make it possible to connect the windings to a low-frequency heater. And the software developed for this method facilitates monitoring and regulating the vacuum level and the heating temperature in real time. This makes it possible to monitor the state of the transformer windings while drying online. This method is best suited for drying the windings of both old and new transformers. In the case of old transformers for which the maintenance dates have been missed, the use of GlobeCore technology allows you to do without changing the transformer for a new one and to keep to the extent of drying its winding. Advantages of GlobeCore technology. 1. Efficiency. The combination of a low-frequency heater and a vacuum oven ensures a smoother and deeper moisture removal process than in the event of each single method. 2. Safety. The approach reduces the risk of overheating the windings, because the vacuum allows the water to evaporate at lower temperatures. 3. Speed. The combined technique can reduce the drying time by up to 50% compared to using, for example, a vacuum oven only. 4. Improved quality of drying. Since low-frequency heating contributes to release of moisture, and vacuum stimulates the release of moisture at an intensive rate, this drying method ensures deep and high-quality water removal. And how do you protect your transformers against moisture effect? What drying methods do you think to be the most efficient? Share your experience in the comments. For more information, please visit our website www.globecore.com.